In this lecture here, we want to now talk about logarithmic differentiation. And so here's what's going on in this. On occasion, it's convenient to use logarithms, and specifically the rules of logs, okay, as aids in differentiating non-logarithmic functions. Okay, when we do this, this procedure is called logarithmic differentiation. So for example, here's going to be two of the first problems we do. So suppose I say, I want you to find, dy dx. Okay, in this case, I'm going to denote it as y prime in our examples, and you'll see why as we go through, for the following. And these are going to be the first two examples we're going to do. First one will be, excuse me, y is equal to x raised to the x squared power. Like, how would we even do that? Or two, something like this. Y is equal to x minus 2 squared divided by the square root of x squared plus 1. So for this one here, like, you could use, you could use the quotient rule, but then it involves the quotient rule and the chain rule, and it gets really, really messy. So what's going to happen here, the procedure with logarithmic differentiation is we're going to start by taking the natural log of both sides. Then what you're going to do is then you're going to simplify using the rules of log. And then you're going to differentiate both sides with respect to x. And then you're going to solve, after that, then you're just going to solve for y prime. Okay? And it's actually really, really, really great once you see this in action. Okay. So let's start off by finding dy dx, or I'm just going to call it y prime for this first one here. Okay. And just to note to help, okay. If I say find the derivative with respect to x of y, okay, if it was u, it was going to be the natural log of y, derivative with respect to x of the natural log of y. If this was a u, remember it's u prime over u, so in this case it's just a y, so this is just going to be y prime over y. Okay, and this is going to help us, okay, when we go to solve, all right. So let's start with this. Let's find dy dx, or as I call it, y prime, same thing, for this. Y is equal to x, and then y is equal to x raised to the x squared power. Okay. So the first thing you're going to do, like, what makes this tricky is that the x squared is in the exponent. So watch what happens when I take the natural log of both sides. So I'm left with the natural log of y is equal to the natural log of x raised to x squared. What do our rules of exponents say we can do? We can bring this x squared down in front. So this is the natural log of y is equal to x squared, times the natural log of x. Now this is great. This is great. So now let's differentiate both sides with respect to x. All right, so recall, when you differentiate with respect to x, the natural log of y, you get y prime divided by y, okay? So this becomes y prime divided by y is equal to, and I just need to use the product rule here, right? So this becomes 2x times the natural log of x plus x squared times, and then the derivative of the natural log of x, we obviously know is 1 over x. So then look what I have here. I'm going to move this up here. I have y prime over y is equal to 2x times the natural log of x, And then this just simplifies to x. So if I want to solve for y prime here, look what I get. I get y prime is equal to, okay, I'm going to multiply y over y times 2x, the natural log of x, plus x. But it's just like, well, this is weird with the y, but what is y equal? Look, y is equal to x squared, or excuse me, x raised to the x squared power. So just substitute back in. So you could even go simplify even more. I could factor out an x. So y prime is equal to x squared times x, 2 natural log of x plus 1. Well, this here would then just be y prime is equal to x raised to the x squared plus 1 power times 2 natural log of x plus 1. So we were able to solve this problem now that we had no procedure for, okay, by just taking the natural log of each side. All right, and then the trick here is when you get this y and you multiply it over to solve, you have to plug back in what y was equal to in the original equation. Okay. So let's now we're going to have to do a crazy one here, and you're going to see that it's going to involve a lot of algebra, okay? So we're going to go back now and solve this using logarithmic differentiation. And the calculus of this problem is not hard. It's the algebra that gets us tricky, okay? So let's find dy dx for y is equal to x minus 2 squared divided by the square root of x squared plus 1. Okay, so we're gonna start by taking the natural log of both sides. So it's the natural log of y is equal to the natural log of x minus 2 squared all over I'm going to rewrite square root here as x squared plus 1 to the 1/2 power. Okay, so again, what we're going to do here is we're going to use our rules of logs. Watch what happens. So the natural log of y is equal to, so division gets split up as subtraction. So this is the ln of x minus 2 squared minus ln of x squared plus 1 to the 1/2 power. Now, rules of exponent, I bring the exponents down. So this is the natural log of y is equal to 2 times the natural log of x minus 2 minus 1/2 the natural log of x squared plus 1. All right. You have to be very, very careful here, okay? So I'm going to differentiate here. All right, so this becomes, so I'm going to differentiate both sides with respect to x. Okay, so now what I'm going to have to do, all right, because you're going to see this is going to be a lot of work. I'm going to continue on to the next slide because there's so much work going on here. All right, so when I differentiate natural log of y, I'm going to go to the next slide. So this is continued from previous. Okay, this becomes y prime over y is equal to. So here, don't forget you have this 2. Okay, so this becomes 2. Now the derivative of this is u prime over u, which would be 1 over x minus 2. Okay, so this just becomes 2, because don't forget, because you have this 2 in front. So 2 over x minus 2 minus 1/2, and then the derivative of this, right? So it's u prime, which would be 2x over x squared plus 1. So minus 1/2 times 2x over x squared plus 1. Okay, so this 2, the 1/2 and 2 will cancel. So I'm left with y prime over y is equal to 2 over x minus 2 minus, so the 2's cancel, x over x squared plus 1. All right, now here's what's really hard, okay? We're going to have to clean this up with a lot of algebra, okay? So you're going to have to combine these, right? So the LCD here is just x minus 2 times x squared plus 1. So y prime over y is equal to 2 times x squared plus 1 minus, and then I have this x, don't forget the x, minus x times x minus 2 all over x minus 2 times x squared plus 1. Distribute, and let's clean this up, and let's see what happens here, right? So I have y prime over y is equal to 2x squared plus 2, and then minus x, so minus x squared minus 2x. Or then, excuse me, minus becomes plus 2x. I almost made a mistake there. Divided by x minus 2 times x squared plus 1. Well, just seeing real briefly what happens here, right? So 2x squared minus x squared, so I'm going to move this problem up here now. So y prime over y is equal to 2x squared minus x, that just gets me x squared. Let's see, plus 2x. And then I have this plus 2. All divided by x minus 2 times x squared plus 1. Now I'm going to multiply the y over. So y prime is equal to y times this x squared plus 2x plus 2 all divided by x minus 2 times x squared plus 1. All right, well now you have to go back, and what was y? Y was this x minus 2 squared divided by the square root of x squared plus 1. And I'm going to write it as x squared plus 1 to the 1/2 power times all of this. X squared plus 2x plus 2 all over x minus 2 times x squared plus 1. Well, look what happens, right? One of these x squareds is going to cancel down here. So the numerator is just x minus 2 times x squared plus 2x plus 2 divided by, so remember, this got canceled out with this up here. So this is x plus 1 to the 1/2 power times x squared plus 1. You can think about it to the 1 power, right? So this becomes x squared plus 1 to the 3/2 power. So you can see here, right, like the calculus wasn't necessarily the hardest part of this problem, right? Like it's all the algebra that is the tricky part of this problem that makes this rather difficult. All right, let me do another one that's a little bit of algebra. So let's try this one. Let's find y prime for, let's look at y is equal to the square root of x squared x plus 2. And let's do this with logarithmic differentiation, okay? So again, you're going to take the natural log of each side. So the natural log of y is equal to the natural log of this. I'm going to write this as x squared times x plus 2 all to the 1/2 power. So I'm going to break this up with my rules of logs. Watch what happens. You have to be very careful. The natural log of y, I'm going to bring the 1/2 down. And then I get the natural log of x squared plus the natural log of x plus 2. Bring the 2 down in front. So we get the natural log of y is equal to 1/2. And then in parentheses 2, natural log of x plus the natural log of x plus 2. Now we're going to differentiate both sides with respect to x. Okay, so we're learning this. We see this. This is y prime over y is equal to. So I'm going to just skip a little bit ahead, right? So, you can leave the 1/2 out, or you can distribute it. It doesn't matter. I'll even factor it out. So 1/2. And then this becomes 2 times the derivative of the natural log of x. So this is just 2 over x plus. And then here you can see this is just 1 over x plus 2 when you take that derivative. Okay, so here what you have to do, unfortunately, you have to clean this up. This is where now the algebra begins. So the LCD here is x plus 2. So this is y prime over y is equal to 1/2. And then you can see here, okay, this becomes 2 times x plus 2. This is just plus x all over x plus 2. So y prime y is equal to, got this 1/2. Here this becomes 2x plus 4 plus x all divided by x plus 2. So now this becomes, I'm just going to multiply the 2 now in the bottom. So this becomes y prime y is equal to, this becomes 3x plus 4 all over, now this 2 gets multiplied in here, that's why I kept it out the entire time, 2x times x plus 2. Now multiply by y, so y prime is equal to y times 3x plus 4 all over 2x, x plus 2. And then again, just final step, substitute in for y. So y prime is equal to y, which is the square root of x squared, x plus 2, times 3x plus 4 all over 2x, x plus 2. And you could tuck this into the numerator if you wanted to, but I'm just going to leave it out here for now, just to save a little bit of space and time. So again, just a lot of algebra, right? Just you got to be very, very meticulous with your algebra. Okay, let's end on a fun problem here. Okay. So let's find dy dx for, let's look at y is equal to x raised to the natural log of x power. Okay, so again, you're going to take the natural log of each side. So the natural log of y is equal to the natural log of, and then here you have x, natural log of x, which is weird. This is weird. So you know what you can do here? Bring this down. Bring this down. So this, the natural log of y is equal to the natural log of x times the natural log of x. So differentiate with respect to x. So here we know that this is y prime over y. is equal to, got to use the product rule, derivative natural log of x is 1 over x. 1 over x times natural log of x is the natural log of x over x. Plus, here you have the natural log of x, and the derivative of the natural log of x, this is cool, is 1 over x, so you get the same thing. So this then now becomes y prime over y is equal to natural log of x plus natural log of x gets me 2 natural log of x divided by x. Multiply the y over. Y times 2 natural log of x divided by x. And then look, what is y? Y is x natural log of x. So y prime is equal to, I'm going to move the 2 in front. 2 times x natural log of x times the natural log of x over x. So just kind of a fun one there with the double natural log, so you could see, you can find the derivative there. All right, so as always, what you've been seeing with these problems here is the calculus isn't necessarily the hardest part, but there's a ton of algebra you need to be mindful of as you work through this. So just, I know I've said this a number of times, but be meticulous, take your time, and you'll be able to conquer these problems.